Okay, this is 4.4 day 1, trigonometric functions of any angle. So far we've been working with standard angles, 30, 60s, and 45 degrees. But today we're going to go back to our basic definitions of sine, cosine, tangent, and so forth. And they are that sine is y, cosine is x, and then you've got some reciprocals. Now, when you're working on a circle and you're defining an angle, the radius is always going to be positive. So at any given point, you can find that radius because you know you're working with a right triangle. So you simply square your x side, square your y side, add those together, and then to find the other angle, you take the other side, the hypotenuse, you take the square root. It's just the same as the Pythagorean theorem. I'm going to show you how that works in the process. This is kind of a long drawn-out page, but I'm just going to do this specific example that shows you step by step. Okay, so if you have the point P, which is 1, negative 3, x is positive, y is negative, what quadrant am I in if x is positive and y is negative? Well, I have to be in the 4th quadrant. So somewhere in the 4th quadrant, I went 1 to the right and 3 down, so I'm right there, approximately. So that's the terminal side of my triangle. Now, if I draw my triangle correctly, I go back towards the x-axis and then back to the origin. This side length right here is 1 because that's my horizontal x value. This side length here is negative 3 because that's my vertical y value. Now, what we need to do in order to find all 6 of the trig functions, sine, cosine, tangent, cosecant, secant, and cotangent, I'm going to need to find my hypotenuse. This is my central angle, by the way, which means that this side over here is the opposite side from the central angle. This is my adjacent side. So finding the hypotenuse is our first objective. Okay, so according to the Pythagorean theorem, if we take a leg squared and add it to the other leg squared, we're going to get the hypotenuse squared. So that's 1 plus 9 equals our hypotenuse squared. That's 10. So if I take the square root of both sides, I have to remember that the hypotenuse is always positive. I'm going to write that up here at the top of the page, and I hope you do too. Hypotenuse is always, always positive. Okay, so the square root of 10 cannot be simplified, so that's just square root of 10. So I'm going to go ahead and label that hypotenuse square root of 10 and label it the hypotenuse over there. All right, now how do I find sine, cosine, tangent, and all the others? Well, the sine of this central angle, which is right here, the sine of that angle is opposite over hypotenuse. So that would be negative 3 over the square root of 10. Now we can simplify that by multiplying by root 10 over root 10, which is negative 3 root 10 over the square root of 100, which is just 10. Now, once we have the sine, we can also find the cosecant, which is just the reciprocal. Now, I'm not going to reciprocate this. I'm going to reciprocate this. I'm going to reciprocate negative root 10 and then 3. See? It's easier to do it that way because then I don't end up with a radical in the denominator. Cosine is adjacent over hypotenuse. That would be 1 over root 10. I'll do the same thing. I'm going to multiply by root 10 over root 10 in order to get root 10 over 10. There's my cosine. Now, the secant, I'm not going to take this and reciprocate it. I'm going to take this one and reciprocate it, which is root 10 over 1, or just root 10. And then finally, the tangent is opposite over adjacent. Opposite is negative 3, adjacent is 1, that's just negative 3. So that means the cotangent is the reciprocal of this, which would be 1 over negative 3. Evaluate, if possible, the cosine function at the following 4 quadrant angles. Okay, so we've actually talked a lot about this before. This is 0 degrees, so this point right here on a unit circle, because this is 1 unit to the right, would be 1, 0. So the cosine is simply your x value, so that would be 1. At 90 degrees on a unit circle, you're right here. So again, radius being 1, this position here is x value 0, y value 1. Cosine is your x value, so that's 0. 180 degrees is over here. Again, on a unit circle, we're assuming that would be 1. So the x value would be -1 and y value is 0 at this point right there, 90 degrees. So since cosine is x, our answer here is -1. And then finally at 270 degrees, that'd be down here. So again, here's the origin. This is 1 unit down, so the x value is 0, y value -1. Again, we're trying to find the cosine for this whole page, so that's just defined as your x value, so that would be 0. Now cosecant is a little different. If we take that same diagram that I drew for 0 degrees, the cosecant is a reciprocal of sine. Sine here is your y value, so if sine is 0, I can also call 0 over 1, because any fraction I can always divide by 1. Now, to find cosecant, I can reciprocate that, so that would be 1 over 0. And you can't divide by 0, so cosecant at this position is undefined. At the 90 degree position, we have the point 0, 1, and so sine would be your y value, which is 1, and obviously cosecant of 1 would be the reciprocal of 1, which is just 1 again. At 180 degrees, we have the point -1, 0. The sine would be my y value, which is 0, and you'd have the same answer as number 6 for cosecant. If you take 0 over 1 and reciprocate it, you're dividing by 0, which is undefined again. And then 270 degrees would be down here, your point being 0, -1 there. So the sine at 270 is your y value, which is -1. Okay, and you can write that as -1 over +1. The cosecant would be this upside down, +1 over -1. But again, you just get back to -1. Because 1 and -1 are their own reciprocals. That's how that works. Okay, this page, I'm giving you some things to think about in terms of if you have sine, cosine, tangent, or cosine, tangent, and all those other things. Where would they be positive or negative? Some people like to think about these rules. I don't actually. I think they're kind of cumbersome. I just kind of think of it as a logical thing, since everything is positive in the first quadrant, and then in the second quadrant, sine and cosine are a little different, but you just kind of construct the answer based on the basic sine, cosine, and tangent, if those are positive or negative, and how you put them together to find the reciprocals. Anyway, if you like to read that, go ahead. It's not for me. Another way to think of the sine function is to remember that what variable it's defined by. So cosine and secant are both connected to x, because that's where you start. This is x, and this is just 1 over x. So it would be the same sine value if cosine is positive, then secant is positive, because they derive from the same original value. Sine and cosecant, they derive from y, and cotangent and tangent come from a ratio of x and y. Okay, now, I've only got about a minute left, so I'm just going to actually show you this page. It says that if sine is less than 0, that means that y is negative, because sine is y, and when you say something's less than 0, you're saying it's negative. So I'm just saying something that's the same thing I'm interpreting here. Sine, which is y, less than 0 is negative. Cosine, which is x, greater than 0 is positive. So if y is negative and x is positive, what quadrant am I in? I'm in quadrant 4. If sine is less than 0, they're basically telling me that y is negative, because sine is y, less than 0 means negative. Now, if tangent is greater than 0, I know that tangent is defined as y over x. Now, if y over x is positive, and I know that sine is negative, that means the top value is negative. In order for this whole fraction to be positive, the bottom would also have to be negative. So, I'll say that again. If the top y value is negative, but the whole fraction has to be greater than 0, i.e. positive, then wouldn't the bottom also have to be negative? Yes, because a negative divided by negative then would only give you a positive. So I've determined, based on the clues they gave me,